So we've already had a look at the proof of is an even integer squared always going to be even, and that ended up being true. So we're going to ask ourselves, does that intuition translate to odds? Is an odd number squared always going to be odd? Well, let's think of some examples, right? Some very common and very good odd numbers to always use is 1, 3, and 5, right? So 1 squared is going to be 1, 3 squared is going to be 9, and 5 squared is going to be 25. And all of these are in fact odd. And the answers will be the same for the negatives of -1, -3, and -5. So I'm going to think the statement's true, so let's try and prove it, right? First, what is the actual mathematical statement we're trying to prove? Well, because it's a for any odd integer, this is going to be a for all proof. We're going to say for all, let's call these D. For all integers D, where D is odd, is D squared odd, right? For a for all proof, you always let, that is the first word that should come to mind before you even turn on your critical thinking. You should say, let D be an integer such that D is odd. Fantastic. One more thing we should probably do, more clearly define what it means for D to be odd so we can turn this word into math. We say then D is going to equal to 2, what letter do I want to choose? Let's choose W. 2W plus 1, where W is also an integer. Since we've already defined D, now there's another letter W, we should define that as well so the reader knows what W is. Now we can get to our proof. We can ask ourselves, let's try this, see if it looks like something that should be odd. So let's put down D squared, or since this is a sentence, we start it with maybe a therefore, or whatever you fancy. We say D squared is going to equal to, we can plug our definition in for D, 2W plus 1 squared, which is going to equal to, so let's expand this. Well, this is going to be 4W squared plus 4W plus 1. Okay, well now you're going to want to ask yourself, can this in any way look like a definition for an odd number, right? An odd number is defined as something that can be written as an integer times 2 plus 1. So we already have the plus 1. We probably want to keep that, so let's not touch anything. So let's look at this side, right? Can we get this to look like 2 times an integer? Well, we can definitely factor out a 2, right? Because 4s are divisible by 2, so we can say 2 multiplied by 2W squared plus 2W. We left the 1 alone, so we can just say plus 1, and there we go. Okay, so all you have to do now is recognize that an integer squared is still an integer, multiplied by 2 is still an integer, plus another integer that was multiplied by 2, which is also an integer, so the sum of any two integers is still an integer. So you should basically just notice that this is still going to be some integer. We don't care if it's even or odd. Our definition of odd does not care what the integer is. So we can then say where 2W squared plus 2W is an integer. Or, yeah, let's write this in one sentence. Meaning D squared is equal to 2 times 2W squared plus 2W plus 1. So D squared is odd by definition. Maybe I actually won't write that. I do say writing by definition is redundant. You don't need to do it. You can just full stop. We can always assume the reader knows the definitions of even and odd and the concepts we're investigating here. So we can just write down in conclusion the statement, and then here you can insert the statement. I'm not going to. I'm just going to say the statement is true. Fantastic. So now we've proven that any odd number squared is always going to be odd.